I know. That's okay. All right. Pay attention to 4, 3, stop talking, 2, 1, slash your trouble really quick. Good. We're going to have 3 vocabulary words that we're going to have to push in the full section. I've already mentioned the word focus. You probably don't know what that is, or it's the microphone meaning in the middle of the parabolic dish. We're going to find a way how to mathematically find the focus. And then when they think about the Directrix, and we already know what a parabola is. So, if you write down your definitions of a vocab, they're very small, because we have to have 2 of them inside. Parabola is the set of all points equidistant. Distant. That means equal in the distance. We just kind of switch the words together. Equidistant means equal in distance. From a point called the focus and a line called the directrix. From a point called the focus and a line called the directrix. The set of all points equidistant from a point called the focus and the line called the directrix. Okay, so now we're going to find out what the focus is. The focus, so very small, we just don't know after focus. The focus is any point on the parabola. Oops, I'm doing the wrong one. A point directly above or below the vertex. Excuse me. So I'm putting up. Next is the Directrix relationship. So we're over the last one. The Directrix relationship. Because any point on the parabola will be equidistant from the focus and directrix. And we'll draw a picture in a minute to help you understand what that means. Any point on the parabola. Everything on the parabola will be equidistant. That means equal in distance from the focus and directrix. Every point on the parabola will be equidistant from the focus and the directrix. I didn't know no mathematician did that. Okay. At some point, I'm going to look it up. So, over here on the right-hand side, we have a problem already done for us. We can go here, and you can use the sentence if you want, and label these things. We know the parabola is the shape. If you turn to your neighbor, I've said this example times. You turn to your neighbor and take a guess as to what this Remember? Hey, Leanne and Alex. What's this called? Leanne and Alex. What we do is a point called the focus or directives. The focus, yeah. And if you look at focus is a point. Directrix, well, I didn't say that. The directrix is a line. So let's label this a focus. Okay, we know this point on the parabola, the minimum was concave up. We were concave up, reverso. What's the minimum point on a parabola called? This is, we didn't list this word, but we know we go opposite, same, the parabola, so what are we finding? The vertex. The vertex. Okay, now the vertex, we use A, H, and K a lot in this class, is labeled H, comma, K. And remember, the vertex is opposite, same, opposite H, same K. The focus, if you notice, is straight above the vertex. Okay? So left and right doesn't change at all. So it has the same x value. The focus has the same x value as the vertex. I'm going to put an H there. Because it doesn't change left and right when we have a concave up or a concave down problem. What does change is the focus is higher. So what goes up and down? Is that your x or is that our y? It's our y. So our y value was 10 of the vertex, plus it moved up so many units. That gap that it moved up is called P. Okay, so our focus, the y value is going to be whatever K was plus P. Now there's an interesting relationship between the focus and the directrix to the vertex. The gap between the vertex and the focus is the exact same distance, or equidistant, the exact same distance from the vertex to the directrix. So both those gaps are equal. So they're both a length of P. So both lengths of P. Okay, I'm in the gap there. Now the focus is a point, but the directrix is a line. When we're concave up or down, it's a horizontal line. So we think of a horizontal line at slope 0. If I was to slash through one of my axes, and then I was on forever, if I can slash in through my x-axis or my y-axis, you're going to know. If I can slash into my x-axis or my y-axis. You can know? I'm sure if you want to know, it's sure you can buy. I slash into my x-axis or my y-axis. Okay? So my x-axis is horizontal, right? I'm okay. I'm slashing through something. I could technically be on the x-axis the whole time. What if that's up here? That would be the y-axis. So the directrix has to be the equation y equals. Again, the directrix is shifted from the vertex. This time it's shifted down. So instead of k plus p, it's k minus p. The k comes from the y coordinate of the vertex. Okay, that's when we have our parabola concave up and down. And I mentioned the relationship between the directrix, well actually I think it's the focus, the parabola, is the set of all points equidistant from a point called the focus and the line called the directrix. But I told you about sound waves coming in. If this is my parabola, and the sound wave comes in and hits the parabola, stay there. The parabola instantly bounces it straight to the focus. That distance is equal to the distance from the point on the parabola straight down perpendicular to the directrix. Okay, so they are congruent. In the geometry, I'll use the tick marks for congruence. So if my sound wave comes in and gets lower, like right here, the distance from the point of the parabola to the focus, I put 2 tick marks this time, it's congruent to that point straight down to the directrix. Every time. So this parabola has to be a perfectly shaped parabola with the focus in the exact position so that when someone's coming in, they go straight to the focus and they bounce off. Let's draw a concave right parabola. If we could, like the guy saying on the football field, is he moving the sound dish up to collect the sound? No. He's going forward, right? So concave right and concave left, depending which direction we're looking at. So we can also look at a parabolic dish, concave right or left. So draw a second parabola with your colored pencils. So I'm going to do it in a pencil. Okay, let's give you color options. Okay, if I do my concave right, then my focus left point here would be my vertex. And the vertex, I'll just put B for vertex. The vertex is labeled H, comma, K. Alright. Let's repeat. We tell them what should be graphed that has to be inside the parabola. What has to be inside the parabola as opposed to outside. It's a motion from the last graph. I heard the conversations over here, which was great. I heard the conversations over here. Has to be inside the parabola. So I can call anyone of you and you'll be able to answer me because you research from anywhere. And I have to be inside. Look at the graph inside the parabola. And focus. Good. So we have this focus. The focus again is where the microphone will have to sit for the sound waves to come in and be able to collect the sound. Now remember that distance from B, the vertex to F, we call P. So the distance from the vertex to the focus is the exact same distance of the vertex to the, look on the left side. That's on the left side. The inside of this is our focus. What's outside the dish on the left side? Directrix. I look at that word. Directrix. Can you see that word? Directrix. So I need to go equidistant. And this time our directrix, and we usually use a dash line for that. Our directrix, actually, can you build this worksheet for me? I think it was blue. It's better than my water. That's your homework. And this time our directrix is vertical, so think about it. What axis that my x and y coordinate with, and I'm slicing vertically. Which axis do I slice through? X-axis. So this time the directrix is x equals. X equals. The other thing is y equals. So you have to think of which axis are you slicing to? You're doing it with us? If you're going horizontally, that's y equals. If you're going vertically, that's x equals. Okay? Now our vertex is h, comma x. Or h, comma k, sorry. Our focus, this time, doesn't go up and down. It went right. Focus is exactly to the right. It's on the same height, but to the right. Which axis moves right and left? The x-axis. So this time the x changed. So instead of h, comma k, the h means a plus p to it, because it went to the right. So h plus p, comma k. The directrix is on the left side. So the x, the other reason why is x equals, needs to start with that x value, which is h. X equals h, but from the vertex going to the left. Is going to the left adding or is going to the left subtracting? Subtracting. And what is that distance that we move to the left? Okay. P. The distance between the focus and vertex and the vertex and the directrix is P. Okay, so now I have a picture of everything. Then on the far left-hand side here, I'm going to give you the equations for vertical versus horizontal. If we have a vertical parabola, so concave up or concave down, the equation for that has to be y equals, which is the curve we're used to seeing, because concave up and down, always been y equals. Y equals 1 over 4p times x minus h squared plus k. All of that looks exactly like what we're used to seeing, except for instead of a, it's this fraction. 1 over 4p. That helps us find the gap between the vertex and focus and vertex and directrix. So that's the equation we use if we have a vertical parabola. If we have a horizontal parabola is left and right. The x-axis is left and right. X-axis, so we need it to be x equals. Very similar. 1 over 4p times, I can't have x again, so it'll be y minus k, because y and k are always together, squared plus h. Okay, I know that's a lot of information, but we have diagrams, and we label your diagrams, so that when we go to do a problem, you understand where the focus goes, where the directrix goes, and you can just refer to the diagram for what formula you need to use. So, that's another thing. We're just going to do A on this worksheet, and then we'll try some of the homeworks together. Identify the vertex, focus, axis, and the directrix, and direction of opening. So it's going up, down, right, or left. Then sketch the graph. Okay. So in that, I like to blow this up so it's not so small. First item. Too big. I have that one back there, but I don't have what to go into. So. Okay, so first of all, we first identify if it's concave up, down, so it's vertical, or if it's a horizontal parabola. And we do that by saying what is mean squared. Look at number 1a. What is mean squared? X. Does everyone see it says x squared? So let's look at our two equations here. Which one has x being squared? The vertical has x minus h squared. So therefore, it follows the vertical equation with y equals. So that means we need to get y by itself. Okay? Let's see. Rachel, how do I get y by itself? Something we added. Look at the 1/2. What is that fraction bar to? Divided by 2, so we have to do the inverse of that. So remember, 2. So times by 2. We must times on the top, though, or it won't cancel out. It's just because the quality goes down and I put it in this way. So we now have y equals 2x squared. Y equals 2x squared. Okay, now you should, we've practiced this for so long, you should be able to see the vertex in that by thinking opposite, same. And when you turn to me, we're going to discuss what the vertex is by thinking opposite, same. So then remember our y equals a times x minus h squared plus k. Opposite, same. Because of the neighbor. Back around, keep talking. Anthony, as they see you talking about this. Okay, you have 10 seconds. No other seconds. 1, 0. Okay, high in the air with your fingers. Show me vertex, please. Place your hands with the vertex of the point, which has an X and a Y. I do not see the right answer yet. Caleb has the right answer. Are there parentheses around the X? No. So I can rewrite this. That's 2 times X plus 0 squared. So opposite 0, what number is actually squared? 0. There's nothing there, right? Opposite same tells me that the vertex is 0, 0. That's one of your answers, so write it down. Okay? Let's start doing the graph so we can start visualizing if this is concave up or down. And on the worksheet I've given you an XY chart to fill in. I'm just going to put that here on the bottom. Remember, we put our vertex in the middle. This one's horizontal, so we can get used to looking at. I'm going to put my vertex 0, 0 in the middle. And then I need a couple X's smaller and a couple X's bigger. I drew it. So look at that. I'm going to hold it there's the check. But on this. Okay, row DC can be a couple X's smaller than 0. -1, -2. And, let's see, R can give me a couple X's bigger. There we go. So now the vertex is in the middle, so we should see symmetry with repeats. Okay, if you have your calculator, please grab it, open it up, turn it on. We're just going to let the calculator do the work. Oops. I wish I could make it super big. How do you get that one? I bought it. This, I see. Nope. It just goes smaller. And then it's large. Nope. Okay, we all do these so that you can see your screen better. Go to y equals. And those calculators should be open and turn on. Clear out anything that's in there. And then type in our solved equation, which is right here. Y equals 2x squared. Y equals 2x, is up by the green off the button, squared. Okay. Now, you can grab when you want to look at it, but we really need the table of values. X is by the green off the button. So how do I go up into the table of values? Second graph or second table. Look above the graph button. It says table. And we just need to get y values from x's ranging from -2 to +2. We get the up and down arrows so we can't see all the ones we need. Okay, let's see what is the y value when x is -2. Allie, what about when x is -1? 2 and that one doing 0, 0? Yeah, so we chose true point. Sebastian, what about when x is 1? 2 and Jake, what about when x is 2? Good. Do you see the repeat? 2s and then 8s? That should happen because both Anthony's regions had wake up. And so pay attention. Go all the way up. That should happen with repeat to tell us we actually have the vertex in the middle and we have symmetry. Okay, so on your graph, let's graph those. Okay, I make this a little bigger. So I have 0, 0, negative 1, 2, with 1, 2, and actually the 8 is off the graph, so I'm not going to graph that. You can see the parabola. Yeah, because I got something 6, so we'll graph the 8. Okay? Just see, is this parabola concave down, concave up, concave right, concave left? Yep, it's going up, right? So part of our answer is the concave up. That's for that. Now we know the focus has to be somewhere inside the parabola. So focus is going to be directly above the vertex. We can find what is that gap that has to be above. And the vertex is going to be directly below the vertex. All of which go through the axis of symmetry. I think it even asks us for the axis of symmetry. Yeah, third one. Vertex, focus, axis of symmetry. The axis of symmetry shares the x-coordinate with the vertex. What's the x-coordinate of the vertex? 0. This is 0, 0. Johnny? That's the symmetry of the line. Let's take the vertical line. By the vertical line, what axis would it be slicing through? The x-axis. Good. So the axis of symmetry has to be x equals. And it's always the x-coordinate of the vertex. So that would be 0. Okay, I think the only two things left to find is the focus and directrix. And we do that by finding the value of p, that gap between the focus and the vertex. Okay, if you look up at our equation that's set up, we have y equals something squared plus k. H and k were 0. In our equation we're working with, is there something multiplying in front of the x? So we have other things, for instance, let's straight up. Is there something multiplying in front of the x? 2. So all we're going to do is take that 2 and set it equal to our multiplier here, 1 over 4p, and then find the value of p. Okay? So I'm going to take 1 over 4p and set it equal to 2. If you go into the space of the other column, that's fine. We're just doing this one on the worksheet, and then we'll do some of the homeworks together. We make it p by itself. Also, we don't want p in the denominator. Allison, how can we get p out of the denominator and move it up? Times by what? That would be moving the 4 up. We would move the p up. Times by p. Okay? So on both sides, times by p on the top. That way, p times by p cancels out here, and p is on the right side, and it's on top. So we have 1/4 equals 2p. Okay? We have we get p by itself now, so we know the value of the distance of that gap. Divide by 2. Could that also be the same thing as timesing by 1/2? If I times by 1/2, does that still cancel the 2's out? The reason that is because of a fraction over here. Times by 1/2 is the same thing as dividing by 2. So I get a fraction. Drew, what's the value of p? 1/2 times 1/4. What's the value of p? You can use spell check. 1 times 1, 2 times 4. 1/8 below the focus, and the directrix is 1/8 below the vertex. Okay? So we just have to find the base of focus is above the vertex. So all it's going to be up. It's moving up, going to be an x value or a y value. The y value, up and down is the y value. So the x value is the same as the vertex. And we can move 75. The y value started as a 0, and now it went up, and then our focus has to be inside the parabola. So it went up 1/8. So we're going to add 1/8. What is 0 plus 1/8? Is it just 1/8? So our focus is the point 0, 1/8. 0, 1/8. Which, when you graph it, is barely above the vertex inside the parabola. So make sure it's on your graph. Just barely above the vertex. If the focus is above the vertex, then where's the directrix? Below the vertex. By how much distance? 1/8. So the directrix, then where's the line? Directrix. It's completely underneath the parabola. So that means this time it's going horizontally. Better we slicing through which axis if we're horizontal. Y, so it's going to be y equals. Sometimes we write x equals, sometimes we don't write y equals. So we're going to do which axis it's slicing through. So it's going to be y equals. The y value of the vertex was 0, and now it just went down 1/8. It's going down, adding, and subtracting. Subtracting. So my directrix is y equals negative 1/8. But I need to graph it. So just barely below the y-axis, or the x-axis is y equals negative 1/8. That's my directrix. So we have the focus and the directrix, which is the same distance away from the vertex, but one's up and one's down. And we would say it's concave up. That's the symmetry of the red dotted line, which goes to the x-coordinate of the vertex. You guys are doing well. I know this is tough. The more we practice it, the better off we'll be. So, we're going to do your homework together now. We're going to do as many as we can. We'll do the whole thing before we leave. Lucky. Okay, that is what I want. Oops, I don't know. Let's put that on it. There it goes. Okay. Oops, I don't do that again. We're going to start with number 1. Keep your notes out. The yellow paper should be visible. So we have all of our formulas and our different markings. With concave up versus concave right or left. Number 1, the first thing we identify is who's being squared. Y is being squared. So y is mean squares. Take a look at how we listen to them. Is it vertical? When up, the meaning is vertical. When sideways, the meaning is horizontal. Is it a vertical parabola or a horizontal parabola? Those are really good. I can't see that. Full arc extension. Vertical or horizontal, and y is mean squared. And mixed reviews. So look at where the squares are. Which one has the y in parentheses being squared? Is it vertical or horizontal? No. So here's the y, right? Y minus k squared. So it is horizontal. You should write horizontally. If it's positive, that means we'll be going concave right. If it's negative, we're going concave left. Because that's where the negatives are. So this one's horizontal. I have to find that one again. So, horizontal means it has to be x equals. Because the horizontal axis is x equals. So we need to solve this thing for x. So it's kind of tricky to know if you're doing y equals or x equals. So it's, we should know which one's squared and identify which direction the concavity is. Let's see how do we get x solved for us when we have x equals. So y squared equals 16x. How do we get x by itself? There's my y. So it's already time. 16 times x, we're going to do the inverse. Divide by what number? 16 on both sides. Divide by 16 on both sides. That should give you room down below. The first period I didn't have that, so completely yourself lucky. I went through and added in extra space. So that is not so squishy. So now we have, I'm not going to write this. I'm going to put over 16. I would go 1/16 in front of the fraction y squared. That's the same thing. I want to see the fraction. That way I can see my vertex is going opposite. Same. Okay. I can see the vertex. What number is being added to the y? This is technically the y coordinate of the vertex. The number is in parentheses with the y. 0, because there's not parentheses, right? What number is after the squared? 0. So our vertex is 0, 0. We can put that in a chart in the middle. And we put it on our graph. 0, 0. Do we want to have information about that, or is there why we came up with 0, 0? Okay, now we have some more points. And our calculator can help us. However, this is slightly tricky. Our calculator only lets us find the equations that are y equals. Our equation is x equals. So when we look at our column of our table of values, we have to relabel the columns and switch the letters. Because our calculator will be y equals. So we want, instead of the x values to be negative 2 to positive 2, we want the y values to be negative 2 to positive 2. Also smaller than 0 is negative 1 and negative 2 because we're going horizontally this time. Something bigger than 0 is 1 and 2. So this is x equals, we're not filling in the x row automatically, we're filling the y row, because that's our variable. Our independent variable, this time is y. X is dependent on what we put into y. So x is the dependent variable. Grab your calculators. Okay, we're going to type it in. Go to y equals, please. Everyone should be practicing this. 1/16 y squared. Let's remember that. I'm going to make it as big as I can. This is about as big as I can go. Clear out what's in there. 1/16 y squared is what we need to type. 1/16 is a fraction, so we always put parentheses around fractions. So parentheses, 1 divided by 16, close parentheses. Now, we don't have a button that is y, because this segment is y equals, so we're just replacing y squared, we're going to have to type x squared. And then let's go to the table. Second table. Now remember, we flip-flop y and x. So the first column is actually y. The second column is actually our x's. So I'm going to relabel mine. This one's actually, so you can see it. This column is actually my y. The input was the y. The first column is what we're inputting in. The second column is our dependent variable, which this time is x. So that's really tricky. So we want to look for when the first column y is -2. You know the x value. The y is -2. Good. 0.25, a nice little decimal. Then y, or the first column, is -1. Good. Does everyone see the 0.00? Is that actually on our list? Yes. Palmer, can you tell me that our first column has a 1, what the x value in the second column would be? Ooh, a repeat, right? Which tells me that the 2 should be 0.25. Okay? So we have 2 points. There are pretty small decimals though on the x's. Well, can 0.25 be a fraction? So 1/4? Should it be counted? You don't know the fractions in the list? I've never seen that before. I mean, the decimal is a fraction of this 1/8. So 0.0625? 1/16, yeah. Okay. Alright, we're going to go and graph those. Now, you use the colors you want. It doesn't say end all coming up. The first period. We put every line as 0.1. But I know I actually need to go to at least 4. So I'm going to say every 2 boxes to the right is 1, 2, 3, and then extend one more box to 4. Okay? And then to the left, we're going to go -1, -2, -3. So I'm skipping every 2 boxes. So each box represents a half. As long as you label it, you can really manipulate the scale to what it should do that. Now the y is -2 to +2. So I don't want my graph to be really squishy, so I'm going to do the same thing. And go every 2 boxes. So 2 boxes up would be 1. 2 more boxes up would be 2. 2 boxes down would be -2. There's -1. Okay, so we have all this point very carefully. That's the one that's off the screen as well. And we should make sure that it looks concave. If this is a positive 116, so it should be concave right. The x is 0.25. So it's halfway across the first box. And down -2. The second point is 0.0625, and down -1, which is almost on the y-axis, but yeah, I didn't go far enough down the plane that only about them. This one's down here at -2, and this one's up here at -1. Okay, so we have 0, 0, which I already plotted. We have 0.625, 1. 0.0625, 1 is really close to the y-axis. Oops. Very good. And 0.25, 2. If you connect those, they are going out just barely. We connect them, they're going out barely. And is it concave right travel as we wanted? good. Okay, inside the parabola is floating what? What's the vocabulary word? The focus of the point. It needs to be in line with the vertex. The vertex is right here, is healthy. My axis of symmetry has to go through that. My axis of symmetry is horizontal, and it's right equally to the shape the same side of the vertex. Yes? Focus on. Okay. It's not normal Russian religion that their children are completely different. They all have different laws. We allow the right China person to go first, they allow the Russian person to go first. Yeah, you have to talk to someone who is from England. I've never been there. Axis of symmetry, known as horizontal. Which axis is it cutting directly through across? It's on the x the whole time, but which one we're cutting out? The y. So you can see y equals. And it goes right into the vertex and shares the same word, same x value. Or actually y value, excuse me, because it's y equals. Which is 0. Now we can play that down. Because focus in the directrix. We'll show it very quick. By taking, see this multiplier? 160. What's the formula is that 116 equal to? No, 1 over 4 P. And there's this picture that can go for you and say, right with me, P is a big number, so all of that. So lots of the times by P on top of both sides. I times it on top, it cancels out. And I get P over 16 equals 1/4. I mean, I get P by itself. And the 16 at the bottom. How do I get rid of that? Multiply by 16. So I get P equals 4. Which means my gap between the vertex and the focus is 4. Okay, so my vertex is here at 0, 0. My focus is on the axis of symmetry. What's 4 to the right? 0 plus 4. 4. So that's why I make sure I label my point as such as my focus. The name of that point. So if the x started at 0, I had to add 4. And y stayed the same. So the name of that point is 4, 0. The directrix has to be 4 to the left of our vertex. And my vertex is at 0, 0. But the left form, what number am I on? -4. It's a vertical line. Vertically, what axis do we cut through? X. So this is x equals -4. We did that by only changing the x value. The x was 0, we subtracted 4. So that x equals -4. Okay? So, you have the homework worksheet. Your job is to try some more of them, and you'll answer questions next time. I know they're like really abstract, and you might be able to test them out. Okay. But if you practice some, and then we can come back and help you out some more. But please try some. Put all the color pencils in the box that's on your row. After school. Really stop the process here.